Okay, we're going to do a problem that's an arc of charge. And so we'll start by drawing it. There's our y-axis and an x-axis. And we're going to calculate the field at a very special point at the center of the arc. And this is a point of high symmetry and convenience, really, that we can do it. Any other point in this problem would be very hard to do. So there's our little dq. There's the dE that it produces, and we're going to call that angle theta. It's the same angle as there. So let's go back to black. And we can label our dE vector and our dQ. The dQ's there, the dE vector's there. And now I want to calculate some charge. The lambda is going to be a constant, charge per unit length in that arc. And now I'm going to write the dE as dE is dQ over 4 pi epsilon naught. A squared, where A, we'll label A here, is the radius of the arc. Okay, so let's write some components. dEx is the magnitude dE times the cosine of theta, and dEy is the magnitude dE times the sine of theta. So that's our little triangle there. Okay, so let's see what we can do next. All right, so let's write dE out, right? Put our dQ over 4 pi epsilon of a squared cos theta, and dEy, and we're going to fill in the dE again. dQ over 4 pi epsilon naught a squared sine theta. So now we have to write that dQ out. That's going to be our next task. So dQ, it's a charge per unit length, lambda, times a little length, and it's going to be a little arc length now. So we're going to make a little picture of that over here on the left. Okay, so here's my little arc length, little piece of that arc. And I'm going to define it in terms of that radius A. So there's the dL, and that's the radius, and we're going to call that little angle there d theta. So d theta and radius A sweep out this dL, so we can write it as a d theta. That's a little arc length. So now dQ is lambda a d theta. Okay, so I think we have everything. There's the dQ, and we have dEx and dEy. So we're kind of all set to calculate. We've really kind of got all the physics now. So let's move to the next page just to kind of write it all out. Okay, so here we go. dEx dQ over 4 pi epsilon naught a squared cos theta, and dQ, well, dEy is dQ over 4 pi epsilon naught. I lost my epsilon naught there. Try that again. 4 pi epsilon naught a squared sine theta. So those are our components. Now let's put in lambda a d theta over 4 pi epsilon naught a squared cos theta, and dEy, we just rewrite that one. Well, let's fill it all in there. dEy, so lambda a d theta over 4 pi epsilon naught a squared sine theta, and then we can cancel out that a and that square on both of them, and it gets even simpler. So let's write it out in terms of an integral. So we'll pull those constants, lambda over 4 pi epsilon naught a now, cos theta d theta, and Ey is lambda over 4 pi epsilon naught a times the integral of sine theta d theta. So it's a pretty simple integral. Let's talk about limits of integration. So let's go back and let's say, well, we sort of pick something. Well, I don't want a full loop, full arc. Maybe we do a different kind of arc. Let's do, oh, that's a terrible arc. Let's try that again. That's better. Okay, so it's not symmetric. So let's say we've got a lower side that we'll call that minus alpha, and we'll call this beta. So our integral is going to go from minus alpha to plus beta. So let's really write it all out. Lambda over 4 pi epsilon naught a, integral minus alpha to beta cos theta d theta, and ey 4 pi epsilon naught a, integral minus alpha to beta sine theta d theta, and voila, we have it. We're done.